Good morning, everyone. My name is Professor Fernando Colmenares Quintero, and together with my colleagues, we are delighted to present our work titled Integrating Emotional Analysis in Energy Transformation and Circular Economy Projects, a pathway to socioeconomic and environmental justice. In this talk, I will share how emotions can be systematically integrated into project management, creating more inclusive and equitable solutions for the energy transition and circular economy. Let me briefly introduce myself. I'm an aeronautical engineer with studies in Poland, Colombia, and the United Kingdom, including a PhD at Cranfield University. Currently, I'm a professor and director of Engineering Research Institute at the Universidad Cooperativa de Colombia and founder of the Berstic network. My work has always been about linking technical innovation with social responsibility, which is exactly the spirit of today's presentation. This presentation is about how emotional analysis can support energy and circular economy projects. By recognizing the emotions of stakeholders, we can design initiatives that not only achieve technical goals, but also promote socioeconomic and environmental justice. Here, I want to highlight three key insights. First, emotional analysis helps us understand community responses more deeply. Second, it enhances stakeholder engagement, creating a stronger commitment. And third, it ensures cultural relevance, tailoring solutions to the values and traditions of each community. Emotional analysis allows us to see how communities truly perceive and react to circular economy initiatives. By capturing these emotional responses, we can design solutions that resonate better with their values and needs. Emotional analysis strengthens stakeholder engagement. It builds a sense of ownership and commitment, encouraging collaboration and long-term support for circular economy projects. Culturally sensitive emotional analysis makes solutions more effective by respecting local values and traditions. Projects that can achieve sustainable results while also fostering social equity. Technologies make emotional analysis possible in real time. Biometric sensors detect physiological signals, while artificial intelligence processes the data to reveal patterns in emotional responses. Together, they provide powerful insights for improving design and engagement. This framework shows the main steps for real-time emotional analysis, from the initial concept to cognitive techniques, pilot testing, interactions, and finally full implementation. Each stage improves accuracy and reliability. The framework began with the integration of biometric sensors, focusing on heart rate, skin response, facial recognition to capture emotional signals. We then added advanced cognitive analysis, including neural networks, to improve the accuracy of emotional interpretation. We carry out pilot tests to validate the framework in real situations, focusing on user interaction and emotional responses. The pilot tests gave us feedback that allowed iterative improvements, refining both sensor integration and analysis algorithms for greater accuracy. The framework was fully implemented in different technology-driven contexts, enabling real-time emotional detections across diverse sectors. With this complete framework in place, we were ready to apply it in practical studies using different methodologies and tools. To apply this framework, we use three main tools: multimodal sensors for data collection, exploratory validation with the Berstic Live platform, and integration with digital twins, virtual reality, and gamification. We integrated different biometric sensors, heart rate, eye tracking, facial recognition, and acoustic analysis to capture emotions in real time. The signals were processed with Python tools and neural networks, always under strict ethical protocol. Berstic Live, we ran exploratory tests using webcams and machine learning. This helped us detect microexpressions, classify basic emotions, and set a baseline before adding advanced sensors. We also use digital twins built in Unity, combined with gamification and virtual reality. These simulations let users interact with complex scenarios while monitoring their emotional responses. Emotional analysis can be applied in many fields. In education, it boosts student engagement and personalizes learning. In healthcare, it improves patient interaction and outcomes. And in urban planning, it helps capture community sentiments, creating more inclusive and sustainable solutions. In energy projects, emotional analysis helps capture community reaction and concerns. This makes solutions more acceptable and sustainable. For example, by monitoring emotions during meetings, project managers could adapt their strategies, leading to greater trust and collaboration with local communities. When working with emotional data, ethics is essential. We must protect participant privacy, ensure informed consent, and manage data responsibly. Without this principle, any technological process would lose its legitimacy and social value. Of course, there are still challenges. We face technological barriers, the complexity of data interpretation, and strong ethical demands. But these same challenges open opportunities to expand emotional analysis into healthcare, education, and urban planning, making solutions more human-centered. Emotional analysis has the power to transform energy projects. It turns them from purely technical solutions into human-centered processes, where emotions guide collaboration, trust, and long-term impact. By integrating emotional analysis into energy and circular economy projects, we not only improve engagement, but also ensure that solutions are inclusive, culturally relevant, and sustainable. This approach is key to advancing both socioeconomic and environmental justice. Thank you very much for your attention. I am very grateful to my colleagues, institutions, and collaborators who made this research possible, and now welcome to questions and reflections.